Eurostar. From the UK to the continent, this extraordinary rail link has been revolutionizing European transport for the last 30 years. Nearly 10 million passengers use the service every year, taking advantage of an iconic feat of engineering that opened in 1994, the Channel Tunnel.
It was an historic moment, not just for the rail industry, but also the travel industry as a whole.
It was a first, a 50-kilometer rail tunnel crossing a sea, 75 meters below the surface. With a train every 4 minutes, Eurostar is now the busiest railway in the world.
Departing on time for a Eurostar is more crucial than for most other trains.
From London to Amsterdam, Paris, Brussels and Cologne, Eurostar is Europe's leading rail network. But running smoothly through 5 countries demands meticulous planning and coordination.
9059, all radio users, doors closing, 9059.
How do you make all the cogs and wheels of an international railway work in unison? How do you guarantee the smooth operation of a link as critical as the Channel Tunnel? How do you orchestrate one of the world's most complex rail systems on a day-to-day basis? Onboard staff, engineers, technicians, we head behind the scenes to meet the experts who keep this crucial lifeline running. Europe's premier rail network, the Eurostar. England, France, Belgium, Netherlands, Germany. In 3 decades, Eurostar has established itself as a major network, an essential link between the major cities of Northern Europe.
We can have up to 6 or 8 trains running at the same time on different routes. For example, trains arriving from London while trains are leaving Paris, departing from Brussels with others setting off from Amsterdam.
Eurostar connects the continent. Right from the outset, this line was inevitably going to be one of the most complex in the world. As well as needing to be operational across different rail networks, it first had to solve the major problem of crossing the sea. The starting point for this ambitious undertaking, then, was a key undertaking, a veritable feat of civil engineering. And without it, nothing else would have been possible: the Channel Tunnel. A visionary idea that had been around for decades, centuries even, was finally given the green light in 1986. And in 1987, the work finally began. 1,200 workers, engineers, geologists, and technicians set out to conquer land and sea. To finally realize this ambition, a tunnel had to be dug beneath 35 meters of water and 40 meters of rock, an undertaking that required some extremely powerful tunnel boring machines. Using 11 in all, they were tasked with digging not 1, but 3 tunnels simultaneously. Underground conditions for the work teams were extreme, given the huge pressure exerted by the English Channel and the seabed, which is 10 times the Earth's atmospheric pressure. During digging, the rock ceiling overhead could collapse at any moment. To avoid such a tragedy, the tunnel structure had to be put in place immediately. Meter by meter, the tunnel boring machines laid the concrete elements that would support the entire structure. Meanwhile, 4 pumping stations were set up to cope with the constant seepage of water from the seabed. After only 6 years of digging, the work was completed on May 6, 1994. 10 million tons of material excavated, 1 million tons of concrete laid. A total of 50.5 kilometers, 38 of them beneath the English Channel. To this day, it remains the world's largest underwater tunnel.
The design of the Channel Tunnel is just extraordinary. It's so sturdy. in terms of the safety coefficients. The more you look at it, the more it seems indestructible.
In June 1994, the Channel Tunnel was finally open to traffic, and the first cross-channel railway link appeared. The Eurostar was born.
The fact that you could go from London to Paris direct on a train through a tunnel was absolutely huge.
Right from the start, the Channel Tunnel was a great idea. Imagine trains traveling at 300 kilometers per hour on land and 160 kilometers per hour, 75 meters underwater for 13 minutes.
Since it came into being, the trains on the network have been in a constant state of evolution. In 30 years, they have enabled 200 million passengers to cross Europe at high speed on both sides of the channel. Whereas previous land-sea links between London and the continent were laborious, with air travel the only rapid solution, the Eurostar line with its tunnel has created a direct link between the heart of Europe's major cities. In England, the day begins at London St Pancras Station. In London, 1.5 hours before departure, train 9022 is all set, standing ready for service under the magnificent glass roof of this historic station. Here, an entire floor has been dedicated to the Continental Link.
Good afternoon. We are very pleased to inform you train 9132.
On site, the local teams ensure that everything is perfect for train 9022.
Excellent news. Thank you very much. Thank you. Bye-bye.
Preparations are made for boarding. Half an hour later, 1 hour before departure, Kevin, the driver, takes over. His first task is to check his work tool down to the last detail. The train's exterior, of course, but above all, its steering and safety instruments.
To prepare the train, the first thing we have to check the outside, make sure that the lights are working, that the nose cone is closed. Then we come into the cab, we have to check that we've got all of the safety equipment available in case of emergencies, and then we have to check all of the braking systems and the safety systems that they're all working.
Backward emergency brake.
It's working well. All tests in the cab are complete, everything is satisfactory. Over.
Departure for Paris is now only minutes away. The driver keeps his eyes glued to the signs. In just a few moments, he will be authorized to set off along the tracks.
Green. People are down.
At 12:04, Kevin sets Eurostar 9022 in motion. The train glides through the London suburbs along the English rail network, which required major changes to accommodate the high-speed rail link between Paris and London, which now takes just 2 hours and 17 minutes. Along the way, the driver's attention is put to the test. Focusing on the track and its control screens, one of his main jobs is to make sure the train has enough power at all times.
The train has a maximum speed of 300 kilometers per hour, which is a very high speed. And in order to power that, it takes 25,000 volts through the overhead power cables. But also the systems of electricity are different in different areas. So we have to change electrical systems at different points in the journey.
As they cross Europe, Eurostar trains operate on numerous rail networks. Different countries have different infrastructures, with variations in the power supply, which ranges from 15,000 to 25,000 volts, for example. The pantographs on the roof of the train collect this electrical energy throughout the journey. They are in contact with the catenary, the electrical cable that runs along the entire line. But every change in voltage requires a new pantograph. Some need to be lowered and others raised to maintain the train's power supply. Time is of the essence. These changes have to be made at precise interconnection points to avoid damaging the entire line. Not too early, not too late.
That is a critical moment when driving the train, because if something distracted you and you selected the wrong system, that could cause problems, like it could potentially break the power cables, and then all the trains would have to stop. So that's the moment when you have to be really concentrating on what you're doing.
After racing through the suburbs of London and the countryside of southern England, train 9022 is approaching a critical point on its route, the Channel Tunnel.
And here is the tunnel entrance. We are exactly on time at the tunnel entrance, to the second.
The Eurostar leaves the British rail network and enters the tunnel. Once inside, it is entirely dependent on the tunnel's power supply, as Eurotunnel has its own independent electrical network. Power management is one of the greatest challenges facing underground infrastructure, and one that carries a huge responsibility. The Eurotunnel must be able to provide a seamless power supply to the hundreds of trains that pass through it every day. At maximum capacity, as many as 16 trains can be running simultaneously 75 meters below sea level. A power failure would spell disaster. To that end, there are two sets of catenaries supplying the 25,000 volts needed for traction to enable maintenance at any time, and they can be powered from either the French or the English side. Voltage is also monitored throughout the tunnel and can be rebalanced in real time to ensure that there is sufficient power for the trains running underground.
Our primary objective, one we've done a lot of work on in recent years, is to provide these trains with a power supply of such quality that they will experience a virtually zero failure rate when crossing the Channel Tunnel.
It's a huge challenge, and to meet it, the Channel Tunnel boasts a wide array of equipment that is as powerful as it is complex. High-tech devices capable of compensating for voltage variations in real time, and robust power supply systems able to withstand the highest energy levels. Of all the installations, the most critical are without question the substations responsible for collecting electricity directly from the national grids. Standing at the tunnel entrance, the French substation is the main source of power for the entire structure.
The whole Eurotunnel grid starts here. This substation is the base for the catenary network powering the trains. It's vital. Without it, we're limited as to how many trains we can run.
While their primary task is collecting electricity, the substations must also transform it into a usable form. From 225,000 to 25,000 volts, and inject it into the structure's circuits.
Switching to local,
To ensure the reliability of the installation, the whole system is checked regularly, in its entirety. And it's a delicate operation.
Leaving ARS and CN concordance.
The power has to be cut on the French side, while the English station takes over. The Eurotunnel is the perfect embodiment of cooperation between the UK and the continent. Everyone is in sync to maintain continuity of service inside the tunnel. On site, the teams disconnect and physically neutralize the installations. Tens of thousands of volts race overhead. Once grounded, they can continue their inspection and see if anything needs attention. The slightest defect on a mechanism, the slightest trace of corrosion, the tiniest alteration to a cable, nothing is left to chance.
We're here every week on Thursday mornings. There's a complete check of the network and substation. We carry out maintenance operations in this substation all the year round.
This vigilance is crucial to ensure a smooth journey for trains traveling under the channel. But it's especially important as the station supplies all the tunnel's electrical installations, as well as the catenaries. Around the historic structure, a whole range of systems and infrastructures are incorporated into the network, including the huge rail and road terminal serving the tunnel entrance, the traffic control center with its countless sensors, and the signaling systems in operation throughout the crossing to keep drivers informed. Last but not least, the network powers the safety devices required for the underground crossing, like the gigantic ventilation system that makes the structure viable.
Ventilation is what makes it possible to breathe in the Channel Tunnel. By definition, a 50-kilometer tunnel is an inert zone. So if you don't ventilate it, you can't stay alive in the tunnel.
In order to circulate fresh, healthy air throughout the entire structure, the Eurotunnel is equipped with a veritable aeration plant. This installation is capable of cooling air and blowing it out at a rate of 100 cubic meters per second, the volume of 2 Olympic swimming pools every minute, and circulating it underground. This constantly renewed air supply is particularly important in one of the key sections of the structure, the service tunnel, accessed by crews on a daily basis. The Sangat shaft, the Eurotunnel's historic starting point, is one of the main entry points for the service tunnel. Right at the bottom, a highly secure access corridor leads to an underground airlock system. Injected air is maintained at a slightly higher pressure. This is an important feature, as we will see. Once through the airlock, maintenance teams finally enter the service tunnel. This tunnel, 4 meters in diameter and positioned between the 2 main tracks, runs the full length of the structure. It is dotted with equipment rooms, piping, and communication systems, as well as connecting areas providing access to the rail tunnels. Most importantly, thanks to this corridor, maintenance and safety teams can intervene rapidly at any point within the structure. Using small, custom-built vehicles, the technicians are constantly on the move.
Yes, no problem. We'll head back to the France portal.
All along the 50-kilometer stretch, every piece of equipment has to be regularly checked. Every light, door, and service telephone.
Yes, it's Julian. Can you hear me? Okay, thanks.
The service tunnel is the subject of so much attention because, as well as being a maintenance tool, it's also the main safety facility for the entire structure in the event of an accident. Every type of incident, from a simple breakdown to a potential worst-case scenario, needs to be dealt with.
There are certain systems which have to be working, which it could be okay for the train to operate on a normal network in the UK or in France. If certain things are not working on the train, it might not be able to go into the Channel Tunnel. So it has to meet those minimum standards.
In the event of an unexpected stoppage, or worse, a fire, the tunnel needs to be evacuated quickly, very quickly. For a Eurostar train, that means bringing no fewer than 900 people to safety from a point somewhere between France and England, 70 meters underground and beneath the sea. To that end, the tunnels have cross-passage access points built into them, allowing passengers to take refuge directly in the service tunnel. They are spaced every 375 meters, which is why Eurostar trains are 400 meters long. That way they are sure to stop in front of at least one access point. This is when the slightly higher air pressure in the service tunnel applied by the ventilation system comes into play. In the event of a fire, when the access doors are opened, the pressure differential will prevent fumes from entering the service tunnel from the railway tunnel.
In the service tunnel, passengers are immediately in a refuge that is completely safe. Thanks to the Channel Tunnel's complex ventilation system, conditions for evacuated passengers will be wholly normal.
At the same time, the ventilation plant on the surface has the capacity to increase its blowing power threefold, up to almost 300 cubic meters per second, should it need to purge fumes generated by an incident in the railway tunnel. Safety systems, power supply management, constant maintenance operations, and rail traffic organization. These challenges are met on a daily basis and allow the Channel Tunnel to handle a world record 400 trains a day.
We're now approaching the exit of the tunnel, about to enter into France.
As Eurostar 9022 emerges on the French side, it is preparing for a return to its cruising speed across the continental countryside. The driver accelerates, gradually increasing his speed from the 160 kilometers an hour limit allowed in the tunnel to the 300 kilometers an hour his locomotive is capable of. However, it is not about accelerating hard to hit maximum speed as soon as possible. Train drivers need to be constantly aware of the constraints around them, such as visibility issues, track conditions, potential dangers, or unseen events in the vicinity.
And this is part of the line where we can do our top speed of 300. Safety is the most important part of driving the train. We need to be able to stop the train quickly and safely in case of any emergency.
The driver, then, is responsible for this fine-tuned speed management, an undertaking determined by complex lane markings, read and interpreted by the train itself. It's one of the special features of Eurostars. Signaling depends on the type of line and the country. Information is sometimes transmitted via beacons directly on the line, sometimes transmitted remotely and received by antenna on the train. In other cases, the speed is directly controlled by the infrastructure itself. Eurostar's trains need to incorporate all these systems if they are to cross Europe in complete safety. Along the way, the driver has to maintain his focus, both on the track and on his screens.
Speed restriction coming up ahead.
On the approach to Paris, as the landscape becomes denser again, the train slows down. Through perfect speed management, the driver manages to stay on schedule. He pulls into the Gare du Nord right on time. It's a daily feat taken for granted by passengers, but essential to the complex management of the cross-channel link.
And we have arrived.
Since its launch in 1994, the Eurostar service has become a fixture in the heart of Europe's major capitals: London, Brussels, Amsterdam. Cities whose historic infrastructures have had to adapt to the arrival of this new type of line. An international train crossing Europe all the way to the UK. All this while making sure that the countries concerned can control and manage the new border crossings. In Paris, Gare du Nord was the logical choice for the cross-channel line. But then it has to fit in with the daily hustle and bustle of the famous station.
The first Gare du Nord was built in 1846, and back then, stations were just landing stages, so there weren't many services. Since 1846, the Gare du Nord has continued to adapt to changing traffic flows and needs. In 1864, the station was rebuilt, and since then it has been enlarged and redeveloped.
Over its 170-year history, the Gare du Nord has seen all the developments and evolution of railways and public transport.
Today, the Gare du Nord handles 700,000 passengers a day, and that's where the challenge lies. We have to be able to provide services for international travelers who don't necessarily speak French, who may not even know Paris, while meeting the needs of commuters who live very close to Paris, or travelers who are just passing through. So these two groups of people need to be managed within the same station.
From its original 2 single tracks, the building has expanded to include 15 platforms, serving a network with increasingly complex switches. But this is just the tip of the iceberg. The station extends underground on 3 levels. The first 2 service platforms, handling passenger flow and directing them to the 3rd underground level, where 3 RER lines and 2 metro lines can be accessed, with a dozen additional tracks plunging to a depth of 30 meters. Today, it is the busiest station in Europe. The challenge was to integrate Eurostar into this incredibly complex mix, with all the rigmarole of managing international connections.
So when the Eurostar arrived, it brought with it a new factor, the aspect of crossing borders. In a virtual sense, passengers actually enter the UK at the Gare du Nord, or at least find themselves in a zone somewhere between France and England. And that's what inspired the current layout. The idea was to introduce a kind of sterilization, to create a hermetically sealed box for people and goods.
Within the station, the 4 westernmost tracks have been exclusively allocated to the cross-channel line. Around them, a so-called sterile zone has been created with a physical and inviolable separation of the tracks along the entire length of the platforms. Above is the overhanging mezzanine, where border crossings and boarding are organized as efficiently as possible in the style of an airport terminal.
The issue of Eurostar stations is absolutely fundamental. Today, when you're in London or Paris, I don't think there's any other place in Europe where you can cross the border in such a short space of time. Here in Paris, you go past the border police, leave France, take 3 steps, and then enter the UK through the UKBF, UK Border Force. So obviously, these are border crossing points which are absolutely key for us and immensely complex places to run.
Every day, at the rate of more than 1 train an hour, Eurostar crews carry more than 30,000 people across the UK border into the heart of Paris. Paris, Gare du Nord station, 5 o'clock p.m. Eurostar train 9022 from London is arriving. The passengers have disembarked, and the train, now renamed 9047, must begin preparations for a new journey in the opposite direction. For the teams on site, the countdown has begun. They have 1 hour to organize the next departure.
Coach 10, there is a ramp with a companion, and coach 14 is a wheelchair assistance, just so you're all aware.
Cleaning the train, loading meals, welcoming passengers. As train manager, Blake is the link between the passengers and the entire Eurostar team.
You good?
All good?
Yeah?
Good, yeah?
Yeah, everything okay with the train?
All good. Well, actually, we have an issue.
He's in charge of making everyone feel welcome and comfortable, but like the driver, he is above all responsible for the train's safety and reliability throughout the journey. As soon as the train pulls in, the train's manager's first task is of paramount importance. He reviews the entire train, starting with its exterior.
We start when a train arrives in the platform, even though it might have travelled already from London to Paris or from Paris to London. We start as a blank sheet of paper, so to speak, so we check the train entirely from top to bottom before it goes out on its next journey. So for us as train managers, we'll start by looking at the exterior of the train. We're checking that none of the windows have been broken during the journey. It's a 400-metre long train, so that takes a bit of time. We're also making sure that all of the parts underneath the train, there are some cupboards and electrical compartments underneath the train, we're making sure that they're still correctly in place.
A Eurostar is made up of 16 carriages in a single section. At almost half a kilometre long, it is one of the largest passenger trains in the world. Hurtling along at 300 kilometers an hour, the train is subject to the usual dangers associated with extremely high speeds. The slightest impact can shatter a fragile part of the bodywork. The train also has to cope with the effects of bad weather so common in Northern Europe, and amplified by speed. Every part must be positioned correctly to absorb the slightest vibration. These monitoring points are the daily lot of high-speed professionals. But when it comes to crossing the sea, the Eurostar's real raison d'être, the train faces some unique challenges of a type never before seen in the world of rail travel, the ones introduced by the Channel Tunnel.
Safety is a crucial part of any railway, especially for us, of course. We have two elements that are different to some other railways that people might have travelled on before. Of course, we have our speed. We're travelling at speeds of up to 300 kilometres an hour. And then, of course, we have the element where we are, at one point during our journey, some 75 metres beneath the surface of the sea. Those two elements are always going to necessitate an extra care.
With its exceptional depth and length, the tunnel creates what is known as a thermal inertia zone. The temperature is around 15 degrees Celsius at all times, summer and winter. As a result, during hot or cold spells, the nature of the infrastructure subjects the trains to temperature differentials that can sometimes reach several tens of degrees. These variations place unusually high demands on the machine's parts and gears. While the crews are busy checking the train down to the last detail, departure time is approaching. In 20 minutes, passengers will be rushing to the platforms. And 46 minutes from now, train 9047 will be heading for the UK capital. There's not a moment to lose, especially as the train manager's attention must now turn to a key element, the powertrain.
If you were running just in the normal countryside in France, in the UK, Belgium, in the Netherlands, that you had a reduced amount of power available to you would be an inconvenience. It would slow you down, it would have an impact on the timetable, but it wouldn't necessarily be a safety issue. As soon as you're putting a train with potentially up to 900 people in a tunnel underneath the sea, it becomes a very different situation.
Whenever one of the Eurostar's 32 engines fails, the crew must ensure that the malfunction is isolated. Because if more than half the engines become affected during a journey, then taking the train into the tunnel and risking a breakdown in the middle of the English Channel is out of the question.
We have to be sure that our train is going to be capable of completing the journey through the tunnel. And that might mean that even in the case of something else happening, let's say in the worst case a fire or an incident with the train, that the train is still capable of removing itself from the tunnel.
Such thoroughness, along with the need to plan for the worst-case scenario, is a legacy of the unique nature of the line and its central infrastructure. The safety of all passengers is at stake. This requirement even extends to equipment inside the train.
So for the safety on the inside of the train, we need to check that the alarm systems are working, the red handles that everyone's used to seeing on trains, we need to make sure they're functioning correctly. We need to make sure that the air ventilation system is working correctly. That's an essential part of people's safety on board. TM1 for TM2, are you receiving? Over.
TM2 receiving.
Yeah, all good for the PIDs on the front half, over.
Everything is in order. In just a few minutes, no fewer than 900 people will be boarding a train ready for departure, while passengers are already checking in for the following train.
Okay everyone, TM1 speaking, just to advise you, boarding starting shortly, boarding starting shortly. We've been practicing for nearly 30 years now how to do it, and with experience we've learned how you can load up to 900 people on a train and do it quickly but safely. Everything that we do in terms of boarding is timed down to the minute. For example, I'm required to start the boarding some 26 minutes prior to departure time. Not 25, not 30, 26, because we've worked out that's how long it takes. And we know that after about 22 minutes, we should have everybody on board. That gives us enough time to deal with any minor issues as well. Mesdames, Messieurs, chers passagers, j'ai le plaisir de vous informer que l'embarquement de notre Eurostar est terminé. Nous allons bientôt fermer les portes d'accès. Pour votre sécurité, veuillez vous éloigner des portes d'accès qui seront fermées automatiquement. À très bientôt.
Everything under control. Eurostar 9047 can finally get underway. In just 2 hours and 17 minutes, it will pull into the UK capital. Gradually, the train accelerates and leaves the Paris region. At kilometer 67, it reaches cruising speed, approaching 300 kilometers per hour. Once on its way, departure schedules and timetables must be meticulously adhered to. A train is never alone on its line. On the contrary, it shares it with numerous other connections running along the same rails, only a few minutes apart.
A lot of people, I think, understand with aircraft that aircraft fly to a slot, that they have a departure slot from the airport and they have an arrival slot to respect at the destination. It's quite similar with railways. The timetables are all written, the trains should fall into their specific part of the timetable. If we don't fall into that specific part of the timetable, we can end up behind a slower train, or we can end up behind a train that's stopping in a station that we don't stop at, and that can cause us delays going forward.
For the Eurostar, keeping to schedule is all the more crucial as it leaves Paris on the busiest high-speed line in Europe, the LGV Nord. Over its 225 kilometers, no less than 30 trains run every hour. These include Eurostars and many other high-speed trains. The slightest hiccup can have consequences for the rest of the day's journeys right through the network. This record-breaking ridership calls for a great deal of fine-tuning and, most importantly, the ability to adapt in real time and on a Europe-wide scale. The impact of a passenger problem in, say, Amsterdam Station needs to be assessed in terms of the consequences for a train running 2 hours later through high-speed traffic in northern France. All this in the knowledge that the slightest error can translate into increased delays for all rail traffic on the continent.
Sur la rame 3205-3206, on a une IMO chez vous cette nuit. J'ai pas la possibilité de l'assumer.
To achieve this, Eurostar is equipped with a control center that can precisely track each of its trains in any territory in its network.
It's the control room's job to closely monitor what's going on at all times. It knows exactly where each train is, where each train manager is, and each driver is committed to ensuring that everything runs smoothly. So it's their job to coordinate all these trains with one another right across these networks.
Here, using the tools at their disposal, the teams can centralize all the geographical, timing, and forecast data for the networks in each country. They keep an eye on all the rail traffic in France, the Netherlands, Belgium, Germany, England, even under the sea.
We've created an in-house map on which we track all our GPS-based traffic, plus ground data, so that we can actually see the speed of the train, where it is, what it's doing, and how it's going. Then, if there's an incident on, say, the French network, we use the tools linked to the French infrastructure. We then pinpoint it, see whether there are trains ahead or trains behind, because it's important to be on top of developments and decide how we're going to handle a situation and how it will pan out.
Donc je peux appeler de la de contrôle. Donc on fait 43 pour 152.
The operators are in direct contact with each crew, as well as with the other European rail companies and the managers of the various rail networks used by Eurostar. In the event of an incident or unexpected breakdown, whether a Eurostar train or otherwise, the control room is able to identify a series of alternative escape routes and determine the optimum way to bypass the incident, even if it means temporarily leaving a high-speed line and rejoining it later. Other companies using the same track are then alerted in order to prevent a domino effect, whereby the incident impacts the entire network. In this way, a potentially dangerous disruption is restricted to just a few minutes delay.
I've got a small change to tell you.
It's not just us. We're in the middle of all the other traffic. So anything we do has an impact on other operators. But all the things they're dealing with also have an impact on us. So that's our job. We have to work in conjunction with them to be as efficient as possible.
The objective is clear. Know everything, anticipate everything, control everything. It's a rule that becomes all the more crucial when it comes to the key infrastructure of the route, the Channel Tunnel. In northern France, on the approach to Calais, train 9047 lowers its speed. This now historic section of track linking the UK to the continent is the most critical point on the Eurostar route. This piece of infrastructure is at the very heart of all the timetabling and dictates the scheduling of departures from stations right across Europe. The 50.5-kilometer structure running deep beneath the English Channel is actually made up of 3 tunnels, a service gallery, and 2 railway tracks, one for each direction of traffic. This configuration allows almost 50 Eurostars to run through it daily, as long as a strict schedule is adhered to. Each train has to commit to a given speed for a very precise length of time.
The tunnel gives us a timetable. Then we have to get to the tunnel, which is the bottleneck. Whatever else you do, you have no choice. You can't get to England without going through the tunnel, and it's one way up and one way down. We really have to fit in with their rhythm and do it their way to get it right and be efficient. So a lot of work is done upstream to keep things moving.
The tunnel is a real funnel. All the more so as the Eurostar is not the only service to use this unique link between France and England. The infrastructure managed by Eurotunnel, an independent company, is also used by freight trains and shuttles carrying trucks and cars. Around the underground structure, the company has developed an impressive boarding terminal. Every day, more than 4,000 trucks and 6,000 private vehicles pass through the tunnel.
Bye-bye.
They are directed to the platforms before boarding huge 800-meter-long shuttles.
Hello, may I have a look? Thank you. Oh, okay. Thank you very much.
Once on board, after some final safety checks, they are ready to head off under the channel with the rest of the rail traffic. Shuttles, freight trains, and Eurostar all run on the same tracks and under the same sea. With a train every 4 minutes, the tunnel is now the busiest rail infrastructure in the world.
F5, I have one stopped. Yeah, we can put it on F5, let's do it.
To coordinate all this traffic, the tunnel operators naturally have their own control room, quite separate from the one used by Eurostar. Using an impressive bank of screens, the teams can keep an eye on the tiniest details and monitor any movement within the structure.
There are lots of different users. We have a daily schedule that we have to stick to closely. And with a departure every 4 minutes, it's really tight. The slightest delay can have a knock-on effect on other traffic leaving from France or England.
Laurent, the transfer's ready. Can I send it right away?
Yes, you can go.
Let's do it.
Added to the sustained rate of departures is another complicating factor, which is that the trains travel at different speeds while actually in the tunnel. For freight trains, it's around 100 kilometers an hour. For the Eurotunnel shuttles, 140 kilometers an hour, and for Eurostars, 160 kilometers an hour, which are restricted for safety reasons. As the day progresses, they need to be released into the tunnel in the right order so that the slower ones don't slow down the faster ones.
Eurotunnel trains run at 140, and Eurostar passenger trains at 160, meaning a fast Eurostar will catch up to one of our trains over a distance of 50 kilometers. So it's up to us to optimize the Eurostar's entries so as not to slow it down in the tunnel. To that end, we may have to hold back one of our trains for a minute or two to enable the Eurostar to hit 160.
Any unforeseen event requires immediate action and constant communication with the Eurostar teams to avoid accumulating delays.
Hello, it's Veronica Thierry. How are you?
On the operational side, our job in the control room is to notify Eurotunnel the moment there's the slightest disruption, and to alert them that we're breaking with the schedule so we can fill any remaining slots and make sure as little time as possible is lost.
We need to adapt constantly, and it's very time-consuming. In fact, as you see, we're in regular contact, so the phone rings a lot. Yes, go ahead.
With the incessant flow of trains through the tunnel, the traffic control centers guarantee the safety and fluidity of this crucial link 24/7. After its journey beneath the sea, train 9047 finally lands on British soil. Just a few dozen minutes later, it pulls into the heart of London at St. Pancras Station, the terminus. Here, on the platforms of London Station, the passengers alight and the train empties. Blake, the train manager, brings up the rear before calling it a day.
We take great pride in our trains as train managers. We consider them like our homes, really, and when we have people on board, it's like they're coming to visit us at home. So you look after them. You look after them from the point they arrive until the point they leave.
After a smooth ride, timed to the minute, the hustle and bustle subsides. For train 9047, the daily shift is done. Over the past 30 years, the Eurostar network has expanded throughout Europe. Considering the line that had so many special features when first created, it was always destined to be one of the most complex in the world.
Obviously, many technological and infrastructure difficulties had to be overcome to create this line and put the trains into service.
Over the years, the network has expanded. After the UK, France, and Belgium, this now essential link connects the Netherlands and Germany.
Europeans can live in Paris, study or work in London, come to see their parents in Paris at weekends. So yes, it really has changed people's lives.
You can't say that that's just a train, that's much more than a train. That's a change in political and social life in an entire continent.
The excitement and the romance of that has continued for nearly 30 years. So, you know, we're so lucky that we can be part of that. People's travel behaviours are changing, and they're changing to a green mode of transport. That's what Eurostar can provide, has provided for nearly 30 years.
Today, the Eurostar punctuates the daily lives of millions of Europeans. It has redrawn the contours of the continent beyond its seas and its borders.